So speaking to increasing and decreasing intervals, we're going to discuss max, min, increase, decrease, round each graph up with the in behavior statement for practice, since we started that yesterday and we have discussed it already. But again, just to make sure you're getting all those parts. I know increasing and decreasing sometimes has been a struggle for some students. So we're on it and we're going to do it and stick to it. And let me know along the way if you run into issues. If something is not clicking, I need to know, because otherwise I'm just going to assume we're all good. So if you don't tell me, I don't know. So you have to reach out. Tutoring every day, and then our live classes as well, or other opportunities other than your Remind app and email to let me know if you're struggling with these concepts. So for our first graph, we know this is an up, this is a down. So this is our positive infinity, negative infinity, positive infinity, negative infinity. This is a -1 leading coefficient and a 3 exponent. So that -1 leading coefficient tells you that this side is going to be down. So your right-hand side of your graph will be negative because the leading coefficient is negative. So starting will end negative. The odd exponent lets you know that whatever it ended, it's going to start in that opposite direction. So speaking back to your in behavior statement. So because of those two numbers, you could not see this graph at all and should know those things. So again, -1 means that the right-hand side or the end of your graph is going to end going down. The odd exponent, because it's a 3 and not divisible by 2, means the other side will be opposite. So odd and opposite is how I remember those things. So our min and max, there is such thing as a relative min and a relative max, and then an absolute min and an absolute max. And I'm going to add these up here just in case. So absolute, min and max, and then relative, min and max. And they also have like local min and max is another verbiage that I've seen people do. And that's just saying in that section. So if it's a multiple curved graph, you can have more than one relative min or relative max. Absolute min and max is definite. It's only one of them. It is absolutely the highest or the lowest point of this graph. No other options. Absolute means no question. Nobody can ask you more questions about it. It is a fact. Can't argue it. Relative means what depends on which section you're looking at. Now, in this cubic function, it has arrows on either end. So that means it's going to go on forever into the positive and down forever into the negative. So that means there's no absolute min or max, because there's no point that it stops. But there are relative. So this is going to be a relative max because it's how high. And then relative min is low. So it's a minimum if I close my window in. So in the window we're looking at right now, we have a relative max and a relative min. The maximum would be that 2, it looks like. Yep. So max is 2 as a coordinate. But when we discuss max, we're only using our y values, so it is a positive 2. So max and min are only your y values because we're talking about how high or how low. So then our min is going to be that -2. As a coordinate is 0, -2. But again, max and mins are going to be your y values only. Now, those max and mins are turning points. This is where you're going to decide where things are increasing or decreasing. So increasing means when I'm reading it from left to right, so disregard these arrows. When I'm reading it from left to right, is this line going down? Like if it was a linear piecewise, like this was just the line and it stopped, is that a positive or a negative line? Those turn points is when it changes direction. So for this side, just this line, is it increasing or decreasing? It is decreasing because reading from left to right, it is going down. So it's decreasing from negative infinity because of the arrow, means it's going this way further than we have paper and time to go, all the way up until 0. Now, these are domains. We are making domains for our increase and decrease. And domains, remember, are x values only. X values only. So our min and max are y values, but our many domains of increase and decrease are going to be x values only. So I'm looking at negative infinity over here on the x-axis, all the way over here to 0, and then it turns. And it turns, and it starts becoming a positive line. So again, you're looking at this as just a straight line. Don't worry about after the turn point for the moment. And that means how far, when it turned, my x value was 0. And then it went up until my x value is 2. So it's going to increase from 0 to 2, because from left to right, it is going up. Then we have a turn point again, and it starts going down from left to right. And it starts going down from 2. So this would be and from 2 until forever, because we have that arrow, so to positive infinity, because that's the right-hand side of the graph. So again, x values only for your decreasing and increasing domains. You're using your turn point, so your min and max, it's the x values of the min and max coordinate that are going to let you know when it starts and stops. We'll go back and do end behavior last on a second video, just to make sure we're staying focused. So if we're looking at max and min, I have a turn point here, and a turn point here, and then I have arrows, right? So there's no equation given here, but I know that it's ending positive, so I know my leading coefficient is going to be positive. I know that they're both going up when we're done, so the exponent has to be even for this function. It has 1, 2, 3, 4 different directions. So that means there are going to be 4 solutions. So it is going to be to the 4th power. So that exponent is even, and it is 4, because it's 1, 2, 3, 4. So things that you should be able to look at the graph and be able to tell about an equation, like per se, let's say if it was like a multiple choice, you would know that the leading coefficient, so the number in the very front, has to be positive. The exponent had to be even because they're both going up, but we can count that there's 3 directional changes, but 4 directional pieces. So we know the exponent is a 4. Now, max and min. So max, this is a max, but it's a relative max because, again, you have those 2 arrows. So relative max up here at the top. Then I have a min and a min. Now, this one is not as minimum as this one, so this is going to be my relative. And then this one is as low as it's going to go, because everywhere that's going to infinity is going up. So this is an absolute minimum. So that minimum is going to be at 1, 2, 3, 4, 5, 6, -6. And then so that's your absolute. Your other min is at -2. Your max, your relative max, is at +1, because remember, max and mins, we're using our y values. So y values for max and min. And then now we're going to discuss increasing and decreasing domains again. So we're going to go from left to right. So as I go from left to right, this is my first turn point, and I'm going to come over here. This line is a negative line if you start thinking about it just linearly. So that means it's going to be decreasing from left to right. This is our negative infinity, positive infinity, because we're only using x values. So it's decreasing from negative infinity until it hits that turn point, or this absolute min. And that absolute min, x value, is 1, 2, 3, 4, 5, 6. So +6. So until 6. Then it turns and starts to go up. Or as I said, if you think about it as a separate little linear equation, so back to like math 1 and math 2, it goes up until it hits that turn point. So it starts to turn at 6, so it starts to increase at 6. And then it's 5, 4, 3, 2, so that +2, because that's -2. And this is a -6. Ooh, whew, good stuff. Glad I caught that. So this is -6 because we're on the negative side. Sorry, so from -6 to -2, it's increasing. So in my case, it's a pink section. Then it turns and starts going down until your next turn point, which is your next minimum value. So from the max to the min, it's going down. It's a negative line if we were to chunk it into pieces. And it starts going down at -2, and that's union, so that means both of the things. So -2, and then it stops going down at +1. Then when it stops going down, it starts to shoot up again. 1. So we're going up until this graph goes off into infinity. So it turns at 1, and then it goes to positive infinity to the right forever and ever and ever. All right, so I challenge you to stop, pause, because this is a quadratic, our third one, and pause the video and see if you can do it. See if you can figure out your max, your min, and increase and a decrease. Or maybe just focus on increase and decrease. But give it a shot. I bet you can answer it. All right, so our maximum point, this is how high it goes. Max is at a +9. So our max is 9. There is no min because it's going to go on to infinity forever. So there is no min. So go on to for infinity forever and ever and ever. So there's not a minimum point at this point. And then we're going to use that turn max. So this guy started from left to right. So I'm starting here and I'm going to the left because I'll just start to read like a sentence. So again, remember, this is negative infinity for our x-axis, positive infinity for our x-axis. And increasing and decreasing domains mean we need x values. So from negative infinity, this is going up. So it's increasing until I hit 1. That's where my color changed or color stopped. It's increasing. Then at that max point of 9, or negative 1, 9, and I just did it again. That should be a negative 1. It turns and it goes down, becomes a decreasing function. So from negative 1 and on forever to positive infinity. All to the right. Okay. So we have another one. So this is much like our first one, except that it's flipped in the other direction. So I have a point, a turn point. No, this is positive. This is negative. So again, looking at this guy, we know our leading coefficient has to be positive because it's ending going up. And we know our exponent, because they're opposite, is definitely going to be odd. But we also have 1, 2, 3 directional changes. So we know that the exponent would be a value of 3. So this is another cubic function. It's a positive cubic function because it's going to the right at the end. It's going up. So our max and our mins, so we do have those infinity going up and infinity going down, which means this max value is a 2. And then this min value is a negative 2. And both are relative because there are the arrows at the end of each side of this function, which would mean that it does go higher and goes lower. But if we were to close in our window and only look from negative 1 to positive 2, this is relatively a max and this is relatively a min. Now, increasing and decreasing, again, those turn points, max and mins, or how far over it's going to go. But again, you're going to switch over to your x values instead of the y values. So from negative infinity, this is going up. If I look at it just like a line from Math 1, it's going to increase from negative infinity until I hit 0. Then it's going to turn, and it starts to go down. And it goes down until you hit 2 on your x-axis, because that's where it turns. So it decreases from 0 to 2. Then it heads back up again for 3 directional changes, or 3 directions, I should say. And that means it's going to turn at positive 2. So, and positive 2 to positive infinity, because it goes on forever with that arrow. All right, again, if you get feeling froggy, pause your video. So these are all of our turn points here. We do have a beautiful arrow here and an arrow here where this goes on forever and ever and ever. It ends on the right going up, so we know our leading coefficient is going to be positive. It has 1, 2, 3, 4, 5. So we know the exponent is a 5. And that's also odd. We know it's odd because the 2 arrows are going in separate directions from the starting side and the ending side. Now our maxes and mins, we have no absolute because we have arrows. So we're going to go down forever later and we're going to go up forever later. So no absolute. We have a bunch of relatives. So because they are max point, min point, max point, midpoint. So we know this is a max, this is a max, this is a min, and this is a min. And those are all relative because it depends on what portion of the graph you're looking at. So it's all relative to the portion of the graph you're looking at. Absolute means there's no chance that it's going in another direction, like any higher or any lower than that point. So we have a max at negative 3. Oh, that's X, sorry, 2. Max at 2 and a max at 1. And then we have a minimum at negative 3 and a minimum at negative 1. And your coordinates are here, so that's kind of helpful. So it may be better for you to write it as a coordinate, but just know that if it asks for the max, it's y values only for max. Okay, so we're going to increase or decrease. So if I start over here, and like I said, I like working from left to right. This line, if I'm going from left to right, is going up. So that's an increase from negative infinity to negative 3, because again, you are using your x values only, and then it's going to go down until our next turn point, which is a -1. So it's going to decrease from -3 to -1. And then it's going to start to increase again because it turned. So from -1, go all the way over until I hit my next point. And that x value is a 2. So from -1 to 2. And also a call out to parentheses versus brackets. When you're standing on this point, it's not going up or down. So if you remember, brackets means that it is definitely, like, it is happening there. On these turns, you're turning. You're not actually going up and you're not actually going down. So that's why this notation is in parentheses. So now we're going to start going down again at 2. All the way over to 4. Again, we're using our x values. So from 2 to 4. And last but not least, you're going to start going up again at that 4 until positive infinity because you have that arrow again. So increase again from 4 to positive infinity. Now, depending on where you look and where you see these, they may not be written in this notation. It could also be written in inequality notation. So from negative infinity, so all the values less than -3. So if x is less than -3, it's increasing. And then for all the values, -1 to +2. So -1 is the smallest, +2. If I put an x, it's greater than -1, but less than 2 is going to be our interval of increase here. And then here we have from 4. So all the values that are greater than 4, that's everything to the right. Both notations are correct, whether it be parentheses or your inequalities. And then so for decreasing, it went from -3 to -1. So -3, -1. So x is greater than -3, which is moving it to the right, but less than -1 because then it turns again. And then again from 2 to 4. So x is greater than 2, but less than 4. For those intervals, it is decreasing. All right, so then our last but not least, pause the video, try it. Come on, you got to figure out if you're going to mess up. You need to know what you're messing up on before you get to the quiz. So we have our mins and our maxes. So we know this is a min because it's down. We know this is a max because it's high. We have arrows though, so both of these are relative because it could go on forever in either direction at this point. Our max value is going to be 0, 8, but we're going to only use the 8, right? So this is 0, 8. This is -2, 0, which is our min, and we're going to use our y value only, so that means that 0 is a minimum. And then again, there's no absolute because it goes up and down forever and ever and ever. Starting from left to right, increasing versus decreasing. So I'm going to start over here at negative infinity, go this way, and my x value is a -2. So that means I'm going to go decreasing. I'm going to show you inequality notation again. So -2 is where it stopped, and we started at negative infinity. So that means everything's smaller, because everything's small that way, than -2. So x, let's see, I'm going to get rid of this. X has to be less than -2. All the numbers less than -2 would be decreasing. And then we see that it starts to increase from -2 to 0. So it increases from -2 to 0. So -2 to 0, less than symbol. So all values greater than -2 but less than 0 are going to be increasing. Then it makes that turn, and then we're headed back down again. And that turn was at 0, and it's all values greater. So 0 to infinity. So that means x values greater than 0 are decreasing again. Now back to our notation with the parentheses and such. So this is getting negative infinity. And both of these notations work in delta math. So choose whichever one makes the most sense to you. So negative to -2, because that's where it turns. Whoops, and that's not increasing. Sorry, that's decreasing. So from negative infinity to -2 because it's going down. We're decreasing. And then we're increasing from -2 to 0 because that's that x value where we change colors. And then from 0 to positive infinity, it's decreasing again. All right, guys, so that's your video on increase and decrease. I'll make the video writing the end behavior statements for these 6, again, just as practice. So check it out. Make sure you got it right. Try it before you watch the video. Go ahead, stick your neck out there. Like I said, nothing to lose. Great job, guys.